Hello Devices 2, this is Professor Late. Today we're going to go over lab number 8, active filters. This is the last lab that you'll have to put into your lab portfolio. So let's begin. The first part of the lab, we're going to cover the first order low pass filter. So we're going to build the circuit in figure 1 and use the readings to fill out table 1. As you can see, I have the circuit from figure 1 already built. So the first thing we're going to do is set the generator, the signal generator, at 300 hertz. Then we're going to adjust the input voltage so that we get an output voltage of 1 volt peak to peak. So we've adjusted the input voltage, and you see that our output voltage is 982 millivolts. We'll call that 1 volt. So to fill out the first row in our table 1, we have our frequency set at 100 hertz. We're going to read the input voltage peak to peak. You see that our input voltage peak to peak is at 99.8 millivolts, so we'll call that 100 millivolts. Our output voltage is at 998 millivolts, so we could call that 1 volt. To find our voltage gain, A, which is that next box, we need to divide our voltage out by our voltage in. And we find by dividing our volts out of 1 volt by our volts in of 100 millivolts, we find that we have a voltage gain of 10. And then for the final box on that first row, we have to find the voltage gain in decibels. So to do that, we take 20 log, and you'll find that button on your calculator to the 5 o'clock of the big round button in the middle there. So you have to type in 20 log and then the answer of our previous box, our A, our voltage gain. And you'll find that our dB gain is 20 dB. Now, this formula and the previous formula you should have probably written down. If you haven't, go back, copy it down, because you'll be using it to fill out the rest of these tables. So I've changed the frequency so we could do the next row on the table to 200 hertz. You can see that our input voltage peak to peak is still at 100 millivolts. And our output voltage is at 995 millivolts. So you can pretty much round that up to 1 volt. So to find the voltage gain and the voltage gain in decibels, refer back to those formulas and then fill out the next 2 boxes. So I've changed the input frequency to 500 hertz. You still see that we have about 100 millivolts in our input, but we're down to 950 millivolts in our output. So you need to fill out your voltage gain and your voltage gain in dB. So I've started the next row with 1 kilohertz. Our input voltage is at 99.8 millivolts, so that's about 100 millivolts. And our output voltage is down to 840 millivolts. So go ahead, fill out your voltage gain and your voltage gain in decibel. So we're now looking at an input of 2 kilohertz. Our input voltage is still 100 millivolts. Our output voltage is down to 614 millivolts. Make sure you plot out your gain and your voltage gain. So I've changed it to the 5 kilohertz. Our input voltage is still 100 millivolts. Our output voltage is down to 298 millivolts. So now I've changed it to the final row of table 1, which is 10 kilohertz. Input voltage still at 100 millivolts. And our output voltage is at 154 millivolts. So finally, step 6 tells us to measure and record the cutoff frequency. The cutoff frequency is when the output voltage is 0.707 of the input voltage. Whatever the frequency is, when you're at about 70% is considered the cutoff frequency. So with our 1 volt that we had at 100 hertz as our output voltage, we could calculate that our cutoff frequency would put us at 0.707 volts. So, or 707 millivolts. So looking at table 1, our volt out, we see that it falls somewhere between 1 kilohertz and 2 kilohertz. So using that as a reference, I tried 1.5 kilohertz. You can see that our output voltage is at about 707 millivolts. So that would be our cutoff frequency. So right there, our cutoff frequency for this first order low pass filter is 1.5 kilohertz. So moving on to the second part of Lab 8. This is the second order low pass filter. Once again, we're going to build the circuit. This time the circuit's in figure 2, and then use the readings from that to fill out table 2. So here I have the circuit from figure 2 built. Step 8 tells us to set the generator at 100 hertz and adjust the signal level to get 1, and that should be a V instead of an F, 1 volt peak to peak. As you can see, I've got it so that our output voltage is at about 1 volt peak to peak. So we can start by taking our readings. So you see that our input voltage is at 1 volt peak to peak, and our output voltage is at 1 volt peak to peak. So our voltage gain, so you take 1 divided by 1, that gives you 1. So we have a voltage gain of 1. And then plugging into the formula to find our dB gain, 20 log of 1 gets us 0. So we have a dB gain of 0 dB. So plugging in 200 hertz as our input frequency, we still have an input voltage of 1 volt and an output voltage of 1 volt. So calculate out your voltage gain and your voltage gain in dB. So now with an input frequency of 500 hertz, see that our input voltage is at 1 volt and our output voltage is also at 1 volt. So we now have a 1 kilohertz input frequency. We see that our input voltage is still at 1 volt and our output voltage has dropped to 789 millivolts. Make sure you calculate out your voltage gain and your decibels. When you calculated it for your decibel gain, you probably ended up with a negative number. That's telling you that instead of having a gain, you're actually having a loss. So now with 2 kilohertz as our input frequency, we still have an input voltage of 1 volt, and our output voltage has dropped to 281 millivolts. Make sure you calculate your voltage gain and your decibels. So now we have a 5 kilohertz input frequency. We still have 1 volt as our input voltage. Our output voltage is at 45.8 millivolts. Make sure you calculate your voltage gain and your decibels. So now we have our input frequency at 10 kilohertz. Our input voltage is still 1 volt, and our output voltage has dropped to 11.4 millivolts. So finally, for step 11, you have to record the cutoff frequency. Remember from the previous low-pass filter that it's 0.707 of the maximum voltage out. Our maximum voltage out was 1 volt. So when we have 0.707 volts, then you're at your cutoff frequency. So here, when we have 1.1 kilohertz as our input frequency, we find that our volt out is at about 0.707 volts. So we can use 1.1 kilohertz as our cutoff frequency. So for the final circuit of Lab 8, we're going to look at a second order high pass filter. So we need to build the circuit that's in figure 3 and use the results to fill out table 3. As you can see, I've built the circuit from figure 3. So the first thing it tells us to do after building it is to set our input frequency to 10 kilohertz and then adjust so that we have an output voltage of 1 volt. And here we have it at 998 millivolts, so that's 1 volt. So we have for the 10 kilohertz row, which is the bottom row of table 3, we have an input voltage of 1 volt and an output voltage of 1 volt. Make sure you fill out your voltage gain and your decibel gain. So looking at our top row, we have an input frequency of 100 hertz, input voltage at 1 volt, and an output voltage of 8.7, we'll call that 8.73 millivolts. So at 100 hertz, we ended up with a voltage gain in decibels as a negative number. So that's telling you that it's actually a loss, so that this lowest frequency is not getting through very well. So here we have an input frequency of 200 hertz, input voltage of 1 volt, and an output voltage of 35.1 millivolts. So here we have an input frequency of 500 hertz, input voltage at 1 volt, and an output voltage at 218 millivolts. Make sure you calculate your voltage gain and your decibel value. So here we have an input frequency of 1 kilohertz, input voltage at 1 volt, and an output voltage at 690 millivolts. So here we have an input frequency of 2 kilohertz, an input voltage at 1 volt, and our output voltage at 984 millivolts. Here we have an input frequency of 5 kilohertz. Our input voltage is 1 volt, and our output voltage is 997 millivolts. We can round that up to 1 volt. So this concludes our Lab 8 second order high pass filter. Remember to fill out all the tables. Well, let's not skip step 17, where we want to measure and record the cutoff frequency. So our maximum voltage out was 1 volt. So we need 0.707 volts. So here we have 708 millivolts. That's pretty darn close. So our cutoff frequency is 1.024 kilohertz. So make sure you write up your conclusions for Lab 8 and compile it all into your lab portfolio, and make sure you write up your conclusion. This has been the last lab that you need to include in your portfolio. Make sure you have your title page, and make sure that you have your table of contents. And that will, along with the rest of these videos, will conclude your lab portfolio. This has been Professor Late. It's been an interesting bye term with you since you weren't actually in here. Hope to see you all in the fall.